Hey everybody, welcome to PDQ Live. I'm Jordan. I'm here with Tara, as always, except for last week when she was too cool for us. And I'm excited for this week's webcast because we have a special guest, Fred Weinmann, who's going to talk security and PowerShell. So there's a lot of misconceptions out there. Some people think that PowerShell is insecure or there are certain things they need to do for security. And we brought in Fred, who is the expert on this stuff, to give us a breakdown on how to get the most secure version of your PowerShell.
Now, Fred works for Microsoft,
Yes,
right?
he does.
And he's in Germany.
Let's ask Fred.
Let's ask him.
Hi, Fred.
And I totally am sitting in southern Germany right now and enjoying the very moderate climate here. So, yeah, working for Microsoft, doing more remote in recent years, obviously. But still, it's always PowerShell and security and PowerShell and security. But some more PowerShell and some more security. So, well, Andrew just ambushed me at some time. They asked me, hey, Fred, why don't you come over and chat a little bit about your interests in daily work here?
We're glad to have you.
Happy to be here.
All right, so before we get started, I interviewed you, or Andrew and I interviewed you for a podcast a while ago, and I was talking about execution policy of security. And you said to me something that still gets repeated to me this day. Execution policy is like putting a rock in your yard and hoping the burglar trips on it. So I guess why is my assumption on execution policy being the best security incorrect on this one?
Well, for several aspects. Reason one, execution policy only targets files. There's like nothing that would prevent me from running a file from, well, code. So let's take a look at that. The good old execution policy. We have some execution policy going around here right now. It's remote signed. Let's fix that because demo doesn't really work all that well if the execution policy tells me, okay, local files are okay. Remote signed means if it's from the internet, you're not supposed to be doing that. So let's say I want it to be restricted. Restricted means nothing is allowed, or I could put it to all signed, which means everything needs to be signed, which is a policy that many would say, hey, do you want to have that? So let's take a look at how that works out. Okay, yes, I'm going to set that only for the current process. So now I've got a file, which is a very, very malicious file that is totally going to ruin your day. Let's try running that.
Ruin our day, Fred.
Fire. Oh, script execution is not possible for non-signed scripts. So great, security measure working. Well, let's see how that works actually out, because I'm now going to say, hey, give me that script code. Oh.
So instead of saying run it, you're basically capturing the contents of the script into a variable?
That is the current plan.
Okay.
So I now have here a console again, VS Code, console being a bit messy, but that's okay. I now have this nice little piece of code ready to run. Great. So let's go ahead and do script block. And I think it was create when IntelliSense doesn't help. Well, let's do without it. And with that, we should now be able to invoke that. And there it is.
That's
Executed.
fantastic.
Now, this is nice and easy, and it works totally fine for any attacker. The problem here is this is still cumbersome, and I'm annoyed with that. And as an attacker, I think I should have the right to run whatever I want. So I'm going to just turn off execution policy again. Once VS Code stops being a pest, I suppose, let's run it all like that. Oh, please don't tell me I managed to actually get the demo gods messing with me again. That is totally not fun. Okay. Let's create a new console. And do that in here once it's done doing whatever it was. Yes, I want get execution policy.
You got a Z in there.
Yeah. It's all signed. Let's see what this is going to give us here. And we have, again, a little bit of a problem. So what is this code supposed to be doing? Let's start with that. We are trying to grab the piece that is responsible for managing the security evaluation. Hey, is execution policy running or not? And then we're overwriting it with an empty default authorization manager, so it stops being a pest. So for that, we need to grab some things, and apparently this call fails to return something as it was supposed to do. Okay, I'm not going to burn up the time of trying to troubleshoot this into finally working after all. In most consoles I've been trying to run this, it worked just fine. Let's see whether we'll have a bit more fun with a plain, unmodified default console. Now, here it works. And if I now run get execution policy, it's unrestricted.
All right. So with that, it kind of showcases that it's kind of a small barrier, but it doesn't do much for those that know how to get around it then.
Exactly. It's a way to annoy your defenders. It's not going to be a significant bother for any attacker, especially when you consider that most Windows machines, if they are deployed as they are, is going to be in restricted language mode by default. So any attacker package knows it'll have to deal with execution policy, and having execution policy disabled or restricted is for them not going to be a warning sign or any kind of, okay, I'm not going to do this. It's just going to be business as usual. So yeah, execution policy is not going to stop anybody who wants to really run PowerShell, but it is going to be a bother for admins trying to legitimately use PowerShell. There's this nice blog post about 15 different ways to circumvent the execution policy, including both of those options and a few more. So Andrew, if you could provide the link in the chat. It's something you can look up and experiment with yourself. So there are ways to make execution policy a bit more of a bother than the other ways, but at least these two options are going to work unless we deploy some actual security mechanisms that are intended to stop the attacker from doing this. So, which leaves us with the old question of how can we prevent the attacker really from running code against us? The second approach to securing our environment is how can we prevent people from abusing PowerShell remoting to do lateral movement. And finally, the last one, how do we track the attacker when they won anyways? We can try our best to nail things down, but we have to accept that at some point an attacker is probably going to succeed somewhere, somewhen, somehow to run PowerShell. So let's figure out when they are doing that. PowerShell is really great in that regard because the tracking capability means we have a lot better insights in what the attacker is doing compared to pretty much any other language that the attacker could be using. This is the main reason why I say trying to fully lock down PowerShell is not helping you. It's just going to have the attacker use a harder to track mechanism. So, how can we prevent execution? There are two key mechanisms for that. One of them is AMSI, Anti-Malware Scan Interface, which comes with Windows. And the other one is something called Constrained Language Mode. AMSI is a mechanism that is automatically enabled with the operating system starting Windows 10 and Server 2016. I assume most production systems are capable of that. And what anti-malware scan interface does is it takes the PowerShell code and gives it to the antivirus and asks them, is this code safe to execute? And then the antivirus should be providing them a useful answer. Now, if you are running Windows Defender for security, AMSI is automatically supported and enabled. For other antivirus vendors, you have to check. Some of them need configuration. It might be an extra feature. It might not be supported. I can't really tell you about the antivirus defenders, antivirus vendors out there and how their products compare to, and integrate that. That being said, let's assume the attacker managed to trick AMSI. It's only so powerful. The other approach is constrained language mode. The problem with one of the key problems with execution policy is it only applies to script files. And well, that's another problem that a lot of antivirus vendors have historically, which is where AMSI came from for the antivirus part. But from the how do I prevent the attacker from running code part, the solution is really something called constrained language mode, which restricts the tools that we have available. So no Windows API calls, no .NET methods. You can't write properties in most cases anymore. It's basically a pared-down, simplified version of PowerShell, where anything that could be abused to break out of the constrained language mode no longer works in the console. And the mechanisms for that are AppLocker and Windows Defender application control. Either of those, you deploy an application whitelisting policy that affects scripts. Once you block scripts by default, unless they're whitelisted, PowerShell will detect this on startup. And it's going to detect that by generating a test file and trying to load it. So if your monitoring can't handle block events correctly, this is going to be a major annoyance when you're trying to track the logs, because PowerShell is in every single start going to check, can it run this completely non-authorized file? And if it can't, it sets the entire console into this constrained language mode.
So with constrained language mode, it's kind of a way of like if you don't want certain commands in there, if they're not added into the accepted scripts, then they're not going to run for anybody. So it's a way to eliminate the type of command list that you might not want to run in your environment.
It's more of a prevent language features, less individual commands. I'll be going into that in a moment. Let's first do a quick demo of what currently is still possible. I can now try to resolve Microsoft.com, which is not going to work because this is a virtual machine with no network access. So this is a totally great check, Fred. You really should not have dared to resolve localhost, which is going to return immediately. So, execution. Okay. Tab completion, dangerous thing. PowerShell, you are allowed to continue. Thank you. So there is one way we can check the current language mode, and by default, this is in full language. Now, this is, however, limited. We can't just select whatever. We have available full language, restricted language, no language, and constrained language. No language and language modes as a concept in general were introduced because of Exchange. Because Exchange Powerful Remote Management needed a way to prevent users from running anything on the remote Exchange session. So that was the original invention. And in no language, we can't do anything, no variables, no nothing. There's no language feature available, only the commands available in your current session. Now, constrained language is the good one that we want to use. And voila, I can no longer run this .NET method. I can't do API calls. And also, this nice reflection method to disable execution policy, it doesn't work anymore as well. Because, again, it uses features that are simply not available. So that's a bit of an annoyance. Let's change it again. I want my console to be great again and, unrestricted. And suddenly, unfortunately, setting properties is not available in constrained language mode, so I can't fix that back anymore. Of course, this I now did manually. I just ran this in the console, and you can't really expect all of your users to accept, okay, right, let's throw away our PowerShell execution capability. So this is, of course, not the way we want to go about this at scale. What we do is we need a group policy or an Intune policy or whatever your mobile device management happens to be. There are different ways. Group policy is the default one that I use for demos because it's very, very easy to do, and I don't have to worry about a service outage ruining a demo. So let's deploy a constrained language mode policy. This has no settings, of course, so edit it. And now, which one is the right one? There we are. Security settings. And for application control policies, AppLocker, we now need to provide the rules to do this right. Now, we can't just put everything in PowerShell in constrained language mode. We have script-based modules that need to run correctly. So what we can do is we can whitelist a PowerShell module. There are different ways to do this, by path, by certificate code signing, whatever we're going to do. And then even though the console is constrained, the module can run just fine anyway. Now, the problem is we currently have an unmanaged state. We really don't have time to fully whitelist, code sign everything, do the whole process here. So we need some startup that at least the default modules can run unconstrained, that we don't have any problems there. And we also can't just whitelist the windows. I've seen plenty of policies in the field where you say, okay, everything which is under C Windows is fine. The problem is under C Windows, there are quite a few folders that a user can actually write to. For example, to submit spooler tasks and things like that. So users could possibly still run code. Attackers know those folders. They are well known. So we don't want to just whitelist everything. So there's this project called ErrorLocker. ErrorLocker is a nice and useful script solution. You can find it on GitHub. And what it does, it scans a reference machine and just it scans a reference machine and then just builds policy sets based on that. Of course, I keep forgetting that for this particular part, I need to switch back to this. So since you already have that command here, it's okay. We disabled it. It should work anyway. So there we are. We now scanned this reference machine, the local server. And under ErrorLocker, we now have here policy files that we can now import into our policy.
And you said that built those policies based on what was on that machine?
Exactly.
Okay. So if you have your developers run that, it gives you a good idea, or not your developer, but your sysadmins or your DevOps, it'll give you a good idea of what you need to have in there then.
Yep.
Okay.
So we now have 59 new rules, and here we are. So what we have is we have the Windows folder whitelisted, but as you can see, we have exceptions. So it built exceptions for every single thing where a regular user would have write access to. We also have a wildcard is allowed to do everything rule for admins. Because when you're using AppLocker as opposed to Windows Defender Application Control, anybody with local admin rights can disable AppLocker by adding a local wildcard rule. So there's no point in locking down administrative consoles. Anything that is running under built-in administrators only applies to consoles that are started as administrator. So this is a great rule to deploy for a quick rollout because it doesn't affect most administrative tasks, but it does affect users. So we have a few rules here. We do have a dedicated DLL rule to disable PowerShell version 2, which is absolutely critical. Why? We can uninstall PowerShell version 2, but any attacker can just copy a fully officially Microsoft PowerShell version 2 DLL and load it from there. Unless, of course, we block the DLL in question. So that's most of what we need to do. There's just one more thing that I keep forgetting where to go for that. Of course, I get the wrong one. Services. There is one Windows service we want to configure, and that is the AppID service. I want this to be automatic, and we can make sure this is like that. AppID service is the actual service implementing AppLocker. So if that one is not running, for whatever reason, you're not going to have much fun with blocking. So, in effect, once we deploy that, it acts the exact same way as the previous one the demo showed with, oh, you're no longer able to use these tools. But for example, modules that are installed on the C program files will still load as expected.
So this is
time.
Oh, I'm sorry. I didn't mean to cut you off there.
No.
But
Go ahead.
So this is something where it's not something you just flip a switch and it's on. You want to research your environment thoroughly to make sure you're not bringing all your systems down when you first enable it.
Absolutely. This is also why we have two separate policies as the output here. One of them is audit and one of them is enforce. What you can do is you can deploy it in audit mode, and it will not stop anything, but it will generate warnings in the event log what it would have blocked instead.
That's a fantastic idea.
Yeah, it is.
So when you're rolling this out, are you putting it in audit mode for a certain period of time and then based on those results generating your actual policy, or how do you go about that with timelines?
Exactly. I have them first categorize the machine, so a reference machine actually reflects what it's being applied to. Then we do an audit mode rollout and monitor for block events, and then we investigate that and see what the impact would be. The experience from that is that for most regular desktop clients, there's exactly nothing happening other whatever your SCCM or whatever team is how they are deploying their packages. Some of them have a lot of PowerShell, and depending on how they do this, some of them run this in user mode, and those would be affected. The ones that they run a system for regular install tasks, it doesn't happen. So it kind of depends on how the software packaging actually works for that it depends on that how large the effort for adjustments and tuning is. It also depends on maturity level of the coding of the company, because getting a grip on your own code really depends on how good your team is at marking the code as your own. Do you already have secure code management? Do you already have code signing? That simplifies a lot of things if you can add that into your baseline as a whitelist to get that out of the signal pool. So it strongly depends on the environment, how much effort the log analysis requires, and consequently also how long you spend in this phase before you can switch it over. So if you are embarking on the path to hardening security, really the first thing I would recommend is getting your admins to use source control for the scripts. This is one of the key tools that you need to do code signing properly, get your code under management properly, no matter how it ends up. So getting them used to the tool so that later on, when you harden the process, ask more from them, at least they are already know the tools. It lowers the barrier because this is a lot less of a technical problem and more of a people problem getting this working correctly.
Okay.
We do have a few. We got a few questions,
Are you ready to take some questions?
Sure, shoot.
and they're all kind of along a similar vein. Okay, here we go. Is there an easy-to-follow guide to signing PowerShell scripts, or does it require Windows Server? Sincerely, Luke B. Skywalker.
Well, the easy way is you can use new self-signed certificate to get yourself a code signing certificate on your local box and use the set authenticate signature command to sign your script with that. So the actual prerequisites is getting a certificate that is useful for you and nothing else. So if you can just, the thing is you can whitelist any certificate. A certificate doesn't have to be trusted. It just needs to be in the trusted publisher store. So it doesn't have to be a full public CA to give you the certificate. You can have an internal CA server role and get a code signing certificate from that, or you can even roll a self-signed certificate. From a technical implementation perspective, my recommendation is having an internal PKI and getting an internal code signing certificate from that authority. And then, well, you can hand all of your admins a certificate. Have them code sign it. Their scripts before they roll it. That works. It's not great, but it is better than nothing. First of all, it gets your admins to already think in code signing. And secondly, you have at least a clear indicator something is not from your own team if it's not signed. The problem with giving every admin their own certificate for code signing, of course, means that, well, if one of them is compromised, the attacker has a code signing certificate and can allow themselves to whitelist their own code. So that's the core limitation with that. My recommendation from a workflow, have your code in Azure DevOps or whatever Git source control solution you have with some automation agent, have a release pipeline that ships the unsigned code into a staging repository, and have an independent task, take that code, sign it, and push it to the outward-facing repository. So that in no circumstance an admin ever has direct certificate control, and under no circumstance the code that you're signing has access to the certificate. That is my approach, both for signing internal scripts as well as for releasing public open source modules after verifying them that they are actually safe to use.
Cool. Couple more questions for you here.
Sure.
Next question. All signed will run scripts that you generate the signature for, or any signed scripts?
It will run any script that is signed by a certificate that is in the trusted publisher store. No, it is not enough that it is signed by a certificate that happens to be from a trusted CA. The publisher certificate itself that signed the script needs to be in trusted publisher.
Okay, that leads us into our next final question. It is from Marcel. He would like to know, securing scripts by signing with custom CA, does it help securing PowerShell? If so, on a scale of 1 to 10, 10 being the most secure, how do you rate the signing?
As an effect, I would rate it on 9. The key reason why I rate it this high is a very simple thing. One of the key prerequisites for you to be able to detect attacker running PowerShell in your environment, you need to have a mechanism to differentiate your own code from the attacker's code, and that is code signing.
All right.
So it's the key prerequisite really for you to be able to tell that, unless you want to maintain a central database of file hashes for all of your code files, which, let me tell you, is the worst solution. Not that stopped one particular customer.
Nice.
All right. We did get a late question in that probably can get up there. What happens if that cert expires? Do they have to re-sign everything, or is there a way just to extend that out?
That is absolutely excellent question. Code signing in general, not just for PowerShell, but for all of them, there has a mechanism where you can also have a signed timestamp on your signed code, for which you need a time authority to sign that. They're publicly available. You can host your own. And if you have a timestamp on it, that even after the certificate expired, it will still be considered valid as long as the signing timestamp is earlier than the expiration time.
That was news to me.
And that is the one mechanism how you can prevent your code signing certificate from being a major pain 5 years down the road. The same holds true for certificate revocation. Let's say you deploy a certificate to all of your admins because you want them to be able to do this fast and do this now before you can get the big pipeline and everything running. Now, if one of them gets compromised, you revoke the certificate. And here's the point. If this certificate is revoked, of course, all the scripts are no longer trusted, unless the timestamp that you also provided, the signing timestamp, happens to be before the revocation time. So yes, get your timestamps on it, and it will save you a lot of pain down the road.
Okay. All right. Well, Fred, I can't thank you enough for joining us on this. This is something I believe I tried to cover this in webcast and it was not clear. So having an actual expert in here was enlightening for me to learn some things. But that's everything for security. Hopefully this gives you a starting point. I think the main takeaway is it's important to do, but if you haven't done the groundwork, then there's a lot of work that goes into it. So just get ready for a project. But in the end result, you will be better off for it. All right, for PDQ, I'm Jordan.
I'm Tara.
Thanks for joining our webcast today. Also, big thank you to Fred Weinmann for joining us and enlightening us. Thank you so much. And if you've enjoyed what you've seen today, make sure to like and subscribe and leave us your comments. We love your comments. Have a fantastic week, and we'll see you back here next time.